little bit of spice.
Hi, my name is Jiyoung. I'm a current ECE student at Cornell.
Hi, my name is Aiden, and I'm also an ECE student. So for our final project for ECE 3140, we created a discrete LED matrix where ours is 5 by 7 because we want to display 8-bit characters on it, and you can use that to relay a message, and you can also use it to do any animation you would want. And so first we had to solder it. So each row has the anodes soldered together, and each column going up has the cathodes soldered together. So then you can select certain lines to select a certain LED.
Yeah. So to control our 5 by 7 LED matrix, we need 12 output control lines. So 5 for the ground and 7 for the power. But right now, our FRDM board only has 8 ready-to-use GPIO pins, and to solve this, we use 2 8-bit shift registers, which only takes 5 GPIO pins to use, and can output 12 control lines. So to turn on the desired LED, we created a function that mapped the LED coordinate into the values that we need to shift into the registers to control the ground and power lines. But there's a problem when you try to turn on 2 LEDs or multiple LEDs that share either a column or a row, because most likely you will be turning on LEDs that you did not want to turn on. And this is where we use multiplexing, which is where we blink LEDs very fast, one at a time. And this gives the appearance that all the LEDs that you wanted to turn on, while not turning on the ones that you didn't want to turn on. So to create this animation that you see now, we coded the display to show 14 frames, which each frame holding the coordinates of the LEDs that needed to be turned on in order to form the said frame. And to display that our code works, we show the message ECE 3140 with a literal ending animation that runs in a infinite while loop. If you see it in person, it's actually a lot better. In the video, you see the LEDs flickering a little, and that's because multiplexing relies on retina burning, which the camera does not have.
Okay, so for testing and debugging on the software side and I guess hardware, we would sometimes not get the expected behavior, so we would test the initial conditions of certain parts of the shift register by plugging in a DMM to certain DC bias voltage points, and we would expect either a low or a high, and depending on that, the DMM would read 0 volts or 3.3 volts. And a lot of the reasons for getting errors like this was because of poor wire management, so we wish that from the beginning we had good wire management so we wouldn't run into issues like this. And then I guess on the soldering side, in our original design, we had a resistor for each and every LED, which was very, very tedious to do, and it would snap off and it was annoying. But we figured out in our very final design, this one, that we only needed an resistor for each power column. So we just used 7 resistors here, which was way easier. And another thing that's easier about this is we did it on a proto board, so it was more structured and easier to solder in general.